Okay, happy Tuesday. Welcome to Working Connections. I'm David Singletary, and my partner in crime, Pamela Brauda. We've been working together for about 10 years at the college now. She was actually my mentor when I started. We are in the last year of our ATE grant for our data science technology program. We've developed a degree. It's running on all cylinders now after a brief respite for COVID. Very strong enrollment. Associate's degree, two-year degree, so we just actually have enough demand from our students and from the built to do a 4-year degree, and we just actually did our KSAs a few weeks ago on that to start working on the bachelor's program. We are also, we have our data science program, and then we have our redesigned information systems technology bachelor's, where we've added an application development concentration and a fintech development concentration. They're all heavily software development, data analytics. And so that's really kind of the thrust of this presentation today. Just a very brief, shallow dive to highlight our secure programming day or module that we're presenting in our Python course at the end of next week, along with the rest of the Python content we're talking about. We're rehashing or updating our courses for all of our programs: software development, programming languages, data analytics, data science, to focus on 3 primary outcomes on those things. We've added a lot of learning outcomes to the courses, which are including AI. They're including DevOps, teaching the software development students that they're going to have to shift left, and then cybersecurity, really, really important. And so that's the focus of this presentation, and again, this module we're going to be teaching. I wanted to do a couple shout outs to a couple people though in the audience first. Sabina Maslin is filming right now, but she is our representative who has been heads down for the last year on the NCAE designation for our college, for our cyber program, and she's been really working hard on it, almost done with that. And Rajiv in the back, the fixture for Working Connections. I did my first Working Connections session with Rajiv, the data visualization back in 2018. And was that your first with Rajiv? Okay. And so we've had a good relationship with him. And the germination, a lot of this stuff, the idea of a lot of this stuff came from Rajiv's high-tech presentation in Salt Lake City a couple years ago, where he did a secure software development workshop, a mini session. I think it was like one of the 1-hour sessions here, talking about the NIST framework and all the really important concepts. And these are things that we need our students to understand, and our built's asking for them. The students need to know what some of these concepts are. They need to know cybersecurity concepts, even though they're software developers. They need to focus on secure programming. They need to know working with AI assistants and their tools. And they need to know, again, the DevOps, or I should say DevSecOps now, because the security is a big part of that. So that's basically what we're doing with this presentation. And we called it Protect Your Python because we wanted to focus on Python because, again, we're teaching a workshop next week, but this is really language independent. We did DevNexus, when was it, last month?
In April.
In Atlanta, a big Java conference, and half of the presentation seemed to be on AI. The other half happened to be on cyber and the concepts we're talking here in Python, but it was all Java. So every language has its own issues with this and their own tools and their own skills that students need to understand. So we're going to talk a little bit about Python, not get too technical. Didn't want to dig in too deeply on it because limited time. They said they're going to shut the lights off on us if we talk too long. So let's go ahead. So we're going to talk about open source software risks. And the big thing, this is the SBOMs, the software bill of materials, and open source scanning tools, and then how we use those tools, and show a quick example, and then just do a conclusion to give you a really brief overview of the concepts that we're teaching our students for. Some of y'all, I know that in Sam's class, it's like this is really nicely dovetailing into this class we're doing this week, the Cyber Buffet, with all the concepts we're learning in that class, where we're getting into even more depth and stuff and getting more frightening information that we're learning about this and how to do this stuff. But that's where we're going with it. So we wanted to start with talking about the risks, and this is kind of a no-brainer, right? Everybody's read about all these bad things that have happened. There's a lot of articles out there. And we thought Python was great because I don't imagine there's many of you that have not touched some Python code just to try some machine learning. You know, it's just a ubiquitous event now for people to try Python, because that's where all the AI stuff is focusing on, contrary to what Java people at DevNexus were saying. And so we have all sorts of things where things like the repository, the PyPy, or what we call the cheese factory, the cheese shop, yeah, where we're getting these libraries and things from, and how we can check and make sure what we're downloading is safe. Pam is teaching a lot of TypeScript in our FinTech program and hitting Node.js, and she grimaces on a lot of the things that are happening when she's teaching this. Oh, they want me to update to this, and it's breaking everything, and what are the problems with this code that we're downloading? So there's a lot of incidents here. I've just got some of these links talking about some of the more recent things, and the PyPy in particular for the things that the packages that might be getting loaded up with malware and things like this.
So it's not like at the Apple Store or the App Store where they won't let you put anything in there that has vulnerabilities in it. PyPy is where you can upload a package and it could have anything in it. And people just download it because they think this is the one that they need for their application to run. And it could be a case where it's been misnamed or they're tricking you with the name, and it'll do part of what it's supposed to do and then it won't. It'll be a vulnerability. But we've got a couple of those indicated here. Are you going to talk on this one, or am I? The software bill of materials? Well, okay. So the software, a bill of materials is what you use in order to manufacture anything. And I first heard about a bill of materials when I was building a house. And so your architect will take the blueprint and it'll hand it to the construction engineer or the superintendent, and they'll take all of the pieces that are necessary to build that house, and then you'll get an estimate based on that so that you can build your house with all those materials. Well, we're using the construction field to talk about programming, and our bill of materials now is going to be, what are all the packages and dependencies and libraries and DLLs that do we need in order for this application to run correctly the way we want it to do? And so that's what the software bill of materials is going to be. The U.S. Executive Order on Improving the Nation's Cybersecurity, and it's number 14028, and it's actually a couple of years old. It's not brand new. It's been around a while, and that's kind of scary because I didn't know about it for a while. And we need to be talking about these things. We need to be learning about these things. So it talks about how you can construct a bill of materials so that your application, you know everything that went into it. And so it does promote visibility in the software supply chain. So the supply chain is going to be when you download things from Node Package Manager or the PyPy or other places where it's open source. You just download and use it, include it, #include, or whatever your command is to do that. And when you create this software bill of materials, it gives you all the important information, like the version number that you're using and what kind of licenses and where the source of that package was from. And so we're going to use that software bill of material with a scanning tool to figure out where we might have some vulnerabilities. So when we generate an SBOM, we're going to use a tool like CycloneDX or SPDX. We've got a couple of them listed here. And they're open source as well. And the format that they output is going to be a JSON file, which is JavaScript object notation. And we do pronounce it JSON, not JSON, which is how I used to do it. But it's a very easy to read format. So the example we have here is where you can take a name as a key and John Doe was the value. And you've got a string of, no, I don't want to use the word string because that's programming, but you have a structure made up of key value pairs. So this key value set could be a person with the name John Doe, age 30, city, New York. And so you could have another person constructed in a separate structure that would have a name of a different name and then an age, different age, city, different city. So this is what JSON looks like. We can read it easily. And so that's why we like it so much, because it's a lot easier to read than XML. And here's some more JSON examples. And I actually used the JSON Statham picture to help my students put together, this is JSON, not JSON. And of course, you've got Jason Alexander, Jason Momoa, Jason Segel, and then Jason from Friday the 13th. So David's going to talk about the open source scanning tools.
Okay, so we've got this, in this case, a JSON formatted SBOM, or software bill of materials. And now what do we do with it? Well, we'll show you an example of the actual SBOM that we generated from one of the tools. And these are the free tools. Again, Sam, it's like, the free tools, and then there's the paid tools. So the industry is going to use the paid tools, but we're teachers, so we're using the free stuff. But it still is adequate to teach the concepts. And so we have a lot of different tools. They find the vulnerabilities. They all look at a database. They have this common database. Typically, it goes into this CVE, which is run by MITRE. But then all these other companies, vendors kind of add on. They have all this added value they add to it for different things that they put in. And so depending on the tool you use, it can go to a different database to get the information on that from. We also have...
Nope. Were you finished on that one?
Nope,
okay, sorry.
Again, licenses, it can help track your licensing, and it helps with legal requirements. And they look at the risks with the software that you've got in your code, in your tools, in your builds, basically. And they'll look at the dependencies and say, there's been a vulnerability recently on this. You need to address this. You need to take care of this. Some of these, again, these free tools, we have Sneak, we have Black Duck. OWASP is a popular one. I went for this example with Trivy because it was a simple example. We didn't want to get into setting up Docker images and things like this for it. And so it's a very simple executable you run, and it looks at the database and shows you the vulnerabilities. So we'll show you the output again. And again, this executive order, and we have the Office of National Cyber Director is coming down saying, y'all need to be using this stuff if you're going to be working with the government, and that kind of waterfalls, cascades down to anybody else that's doing software. And it's really just a good idea to know what's in your cargo hold, if you want to do it that kind of a Rust reference there, to know what's in that software application that you developed with all these dependencies that you might have naively just downloaded stuff because it was the latest version or it required this particular version for it. And so it's going to generate a report that shows the vulnerabilities and possibly give you insights, again, depending on which tool you use, insights, how you remediate this stuff, what updates you need to make. Okay?
So this one indicates the CVE database. It's kind of plain. It's vanilla. But the other databases are the ones that are going to give you the added value and extra information that are going to be in that report to highlight those vulnerabilities.
Okay, so we've got to walk through. We're going to just show the process that we went through for this. These scenarios, you're developing a Python application, and you're just downloading all the things you need to import. And we're going to show an example with some of the more popular data science libraries, which are Pandas and NumPy, as well as scikit-learn. And I think we're using requests for the HTML. And so a few different packages we downloaded on purpose to generate this report with, which are fairly commonly used. And we're going to use a tool with this. We're going to use a Cyclone DX, which is a different tool, not the Trivy. And you'll actually see a kind of a side effect of using that tool instead of Trivy. And generate the JSON SBOM. And then we're going to use a Trivy scanner to scan that SBOM, and that's going to generate the report, which is very readable and very accessible.
So we're not going to run this code live because it would take too long. We don't want to keep you here past the time to draw the numbers for the fabulous prizes Christina and Mark have for us. But this is an example where we are just taking a look at what's in the SBOM that was created by the Cyclone DX. And as you can see, the curly braces are going to be the structure of the JSON file. And then you have components, and then the next item is going to be an array of other key value pairs. So our BOM ref is generated automatically by the Cyclone DX. The name of the package is scikit-learn, which does have some dependencies. It needs NumPy, it needs Python, it needs SciPy. So it has dependencies that are going to also be scanned at the same time and identified. And it's a library, it tells us what the version is. Some of the dependencies, they're not all listed because we had too many to list, and this is just kind of to give you a brief idea of what it looks like. But your reference is going to be, that reference number is the same as what we had up here in the bill of materials reference. And then the metadata tells us when we did this and what kind of tool we used and what was the version of that tool. And our serial number here is a unique identifier, and one thing we learned is that UUID is the unique user ID or globally unique identifier. Microsoft is the one that uses the GUID. I only thought they were GUIDs, and I didn't know that UUID was the same thing. So we're learning this stuff as we go along. We're not trying to make it up, but we are learning it as we go along. And then the schema it points to a location that has the structure and the validation rules for that particular document. All right, this is when we run.
Okay, so you got your SBOM generated, again, just a JSON file. And so now we're running it with the JSON, the Trivy tool, which this is just a DOS example here where we're running it from the command line, Windows command line. And you see we're calling it the Trivy tool. We're saying we're going to use an SBOM to generate this report, and we're using a JSON-based SBOM for this. And it runs a report. Now I've truncated a little bit of the output here because it is a little more verbose, but you can see that it's talking about the vulnerability scanning, and it's showing how the SBOM was generated. And you can see here that Trivy doesn't like the fact that we didn't use Trivy to generate the JSON file. It's complaining that you got a third-party SBOM, but they have to work together. And then we are showing what files we're scanning, and then it's going to show the vulnerabilities on the next slide. Now this is tabular format. When you run Trivy, it's actually going across, but I didn't want us to be scrolling right on these slides here. So broke it down into a vertical format. But you can see the information we get from it, that we're getting the request library, which is for doing HTML or HTTP requests from Python programs. And you see the CVE reference. This is the vulnerability it found that you can cross-reference into that CVE database. The severity is medium. The installed version versus where it was fixed. So installed was 231, and I back-revved some of these on purpose to make sure we generated these vulnerabilities. The fixed version is 232. You get a title for the vulnerability, a little bit of a description, and then the verification is the link. In this case, it's using the, I think it's called Aqua, the vendor that's providing the database, which is layered on top of the CVE database. And so you see you've got a CVE reference number in there, but it's going to a different site for that information. And so Trivy is using this Aqua site for the vulnerability information on that. And then we use scikit-learn, and there is a medium severity vulnerability there. On version 131, it's fixed in 150, and possibly sensitive data leaks. It might be more than medium severity. And then the links, the same information we got from that. And so that's really the process. You've got this document. Now, this is a very manual process that we just went through, but this is intended to be part of the standard continuous integration, continuous delivery type cycle, the DevOps things that we teach our students. We want to automate this in the pipeline so that you have these things being generated and run every time you have modifications made to the code, add new modules, make sure you've got these checks going on, and then take action on them. Of course, you don't want to ignore them. And so, again, we mentioned that we can check for licensing issues, and we have all the other languages that also have the tools to do this stuff. There's a lot of Java tools for this, a lot of Node.js stuff we can do. Those are the repositories that we're getting this stuff from that you have to be checking on because it's, again, it can be very risky when you do some of this stuff. And again, the pipeline, we can automate this to make it continuous and kind of take it so we're not having to do this manually every time. And one of the big things here is the community maintenance. So these repositories are maintained by a community of experts, hopefully SMEs in these programming languages. And there's a lot of peer input checking these things to not let this stuff get in. Stuff gets in, but it gets caught pretty quick. But if you have older versions of software that you're using because you don't want to break your build, you've got this revision with this combined with this and this, then you might be a little bit complacent. That's the little last bullet here, beware of complacency. You want it to be maintained and be compatible so you don't break your build, but okay, now they found a vulnerability, you're going to have to go through the process of getting the new version integrated with the rest of the tools, the rest of the modules, so that you can get it fixed and updated. And so it's risk mitigation and applying patches and regular scans on this automation.
And we had an example of this where complacency, maintaining compatibility can introduce vulnerabilities, where we kept this one package for an application we were using in my scripting class. And when I
Flask.
went to install, it downloaded all the new stuff. And so that broke what I was using. I had to go backwards to old stuff, to old packages, to older versions of packages so I could get the thing to run. And so we need to update that whole application so that it uses the newer packages because they're going to be more secure. So it's tight. Takes time to update those applications. You can't just, like plug them in. Sometimes it breaks something else again. So it's a continuous process, and it can be very time consuming, but it's definitely something we need to teach our students how to do and at least be looking at our programming with a mind to this.
Absolutely, yeah. So, software development, the landscape is changing so rapidly in the last decade. And data and software, so the data analytics courses, anything that touches software, whether it's doing data analytics or software development, we want our students to get these concepts. And so that's why we're adding them into our programs for this.
And I am giving my course where I teach JavaScript and TypeScript today because I hate it. I cannot stand how it's so loosey-goosey. Let's just download all of these packages. We don't know what's in it. We're just going to download it because it makes it work. It gets rid of all the red lines in my code. And that's just so scary to me.
I'm starting to like TypeScript. I don't know.
He likes it. I'm not a fan.
Okay.
Okay.
Questions? Absolutely. No, the question was, can we streamline it, put it into a secure coding class? And this is the automation. This is the DevOps portion where you're going to be putting it in a pipeline, and they need to know how to do the scripting necessary to support that pipeline, do the GitHub actions and things like that. So yeah, absolutely. We are looking at a secure development AS program, possibly. You do programming, it's got to be secure anyway, right? But we want to emphasize it. This is not just your standard learn the language. We are going to be emphasizing these security concepts. So.